Can you improve your Prusa print quality by upgrading to a full Bondtech extruder? Let's find out. Hello everyone, Chris here, and yes, today we will be upgrading to the full Bondtech extruder on my Prusa MK3. And a lot of you have probably heard of Bondtech before if you're into upgrading 3D printers. They make very high quality replacement parts. And one of the biggest advantages of the Prusa MK3 was the fact that it came with genuine Bondtech dual drive gears on the extruder. Prusa just designed their own housing to use those gears. Now, doing an extruder upgrade on any 3D printer probably doesn't make all that interesting of a video. But this extruder is just a bit different. And the biggest reason why I wanted to try this kit out is that Bondtech actually worked with a lot of the community members to design this whole thing. This upgrade will work on your 2.5 or your MK3, and you can take a look at all the information on their page, but if you scroll to the bottom, you'll get a list of all the people that were involved to co-develop this extruder. So I found that somewhat intriguing. And since the MK3 came out, there have been some questions about print quality and whether the Bondtech gears or the housing caused some issues. So I thought all of these things combined could make for some interesting results. So that's what we're going to do today. We're going to take some prints off the base setup. We're going to upgrade to the full Bondtech extruder, then repeat those prints. So let's get into it, and we're going to start today's video with a time lapse. So now let's take an up-close look at some of these prints. And I want to remind you that there's very harsh lighting in here. We're using gray filament, so this is going to give you the best chance of seeing print issues. And when you're looking at them under high res like this and then trying to compare them to your print results, it's not real easy to have an apples to apples comparison. So just keep that in mind when you see some of the print quality here. So let's start with this 6-sided polygon that I've been testing with lately. It only has one exterior layer, and it shows a lot of the imperfections that you can see with a single wall print like this. We're mainly interested in how the layers got laid down. You can see a little bit of imperfection in there. It's still a really nice print, but they are a bit uneven. Also notice if there's any ringing, because the new Bondtech extruder should be just a bit lighter. If you tilt it just right, you can see some of those vertical artifacts. But the main one that you'll see with the Prusa extruder, you have to kind of see it from the side. And you can see all these 45-degree lines right in here. That's the biggest issue a lot of MK3 users report. And you knew you weren't going to get out of this video without seeing a couple of benchies. But now's a great time to mention that all these prints were done with stock Prusa profiles. The ones that come in Prusa Slicer. I use the 0.2 layer height normal settings. They are pretty quick. 2 perimeters, 5 tops, 4 bottoms, 20% infill. Except on the single wall prints, of course. But the benchy's not looking too bad. It's not the best one I've ever seen, but you can see a lot of the typical issues here. You have some retraction problems up here in the smokestack. You can see some inconsistency. These are usually caused by when it runs up to do the bow portion and then comes back. But definitely a good effort for the MK3. Again, stock settings. Then I did a 40x40 calibration cube. These are good because you can see the artifacts as it creates the letters, if there's any ghosting or ringing. But notice mainly all the layer consistency here. You can see it dances around just a bit, and it changes all in how you hold it to the light and what angle you look at. If you hold it just right, you can even see some vertical artifacts. they're pretty noticeable here on the side where there's no letters as well. Top finish, really nothing to report here. Then I wanted to do something that was a little bit bigger, but didn't take up a whole bunch of time. So this is a 2-wall print, just no infill or top. Here I think is where you can see the issues be the most noticeable. You can really get a good idea from this print about how you start to notice those inconsistencies in there. Again, if you hold it in the light just right, you can see those 45-degree angles as well. So there's a look at the baseline prints, and I did quite a few tests. I just showed you the ones that I thought showed the inconsistency the best. And remember, when you're looking at your print quality, it might not look exactly the same on every printer. Also, this is all the same filament with all the tests off the same spool. This is Jesse PLA from Printed Solid, Gunmetal Gray. Now let's move to the upgrade portion, get everything installed, and then try these tests again. So, what comes in the box? And you know how I like packing, and Bondtech is no slouch. Everything they put out is always really packed well. We get our Bondtech sticker. We have printed parts, some PTFE tubes, zip ties, a new motor cable, and some screws, hardware, idler. You do get the collet clip for the hot end. That's good. Remember, this is designed for the Prusa MK3. And then on our second tier, we have our housing with our pancake motor. This whole thing is SLS printed, but it's really close to the MK3 body. This is the MK3S, by the way. There are a couple of different versions. But this will hold your Penta. It has a place for that new type of filament sensor. This should be a direct swap out. And given that it is SLS printed and the way it's designed, it should be just a bit lighter. Also, it is important to note that you're going to use your stock Bondtech gears from your Prusa inside here. So there's your basic kit. This whole assembly right here runs around $110 US. But with Bondtech, you're probably pretty used to that price structure. I know you add $110 to your Prusa kit to make it print even better. That might be a little bit steep, but depending on the print quality, it might be worth it. We'll find out. Also on the Bondtech site, they have this STL file to help you cut the PTFE tube that goes down inside the V6 hot end. You park your V6 in here, and then you cut it on this line. It is relatively short, but this might be worth your while. Go ahead and printing it out to make sure you have the right length. Now, depending on what version of MK3S that you have, you're going to have to change up your X carriage a bit. On the Bondtech site, they do give you the links to the STLs that they'd like you to use to fit up to this extruder, but I believe these are both revision 2 parts. My current printer has revision 4. Now, the advantages to using the revision 4, that's mainly because of the extruder. So this extruder modification will circumvent those revisions, so these parts should be just fine. But just note, if you have a newer one, you might have to fall back to these parts. I would go ahead, if I were you, go ahead and print the ones that are on the Bondtech site. I'm using black PETG, and we can swap in our hardware into these new parts as we put them on the printer. For those that don't know, this is the X carriage back, and this is the backing plate that covers it up, just like this. So back to our printer. Let's go ahead and preheat and unload that filament. Once we're unloaded, we'll go ahead and let it cool down, then we'll power off, and we can start taking things apart to perform the upgrade. So for the revision 4 style, we're going to switch to that other plate. I'm going to go ahead and remove this backing plate. I'm going to cut the zip ties off of this wire loom because we will have to pull them through. We're also going to run a new extruder cable that comes with the Bondtech kit. So we have 2 screws up here, one in the middle, and then one down below next to the heater wires. You can kind of see it in there. So we'll cut the zip ties. We'll just loosen up our cable sleeve. We will have to pull all the cables through, and then we'll back out those 4 screws. So I've just backed out the screws and left it loose for now because I think it's easier to work from the front of the printer to remove everything rather than go ahead and cut these zip ties for the X carriage and let it fall. So we'll switch to the front and work on that side. So we'll take our top cover off for our filament sensor. We'll unplug the filament sensor from the back here. And we can take the filament sensor out. That is a 2mm screw. Be kind of careful with this one. You don't want to touch that sensor housing. Then let's take our part fan off. We'll just let that fan hang for now. Let's move to the side and take our hot end fan off. This bottom one here will remove the part fan duct. Then we'll take the other 3 loose. Then we can let our hot end fan hang here just for now. While we're on this side, we can go ahead and remove this idler screw that holds the door on. This is what keeps the gears tight around the filament. Careful, there is a spring in there. Then on the other side, we can loosen up our pin to probe mount. And we can pull that out. So we're free there. Then we have a screw right here, and then one just like it on the other side that actually holds this whole body on. I'll show you that one. Right in there. If you have a ball-ended Allen wrench, we can go ahead and pull these 2 out and bring that whole housing down. Just get those 2 loose, and then from the back side, one more time, we'll loosen up this one here. These go all the way into the motor. Remove that one. And then the one on the other side goes into the motor, but it also holds that idler door on. So we'll pull that one out, pull off our door. We have to reuse this gear, by the way. And then back to the front. This whole thing will just fall forward. Now we don't have to reroute everything as far as the wires go. The biggest thing is this extruder motor because we're going to change to a smaller one. But we want to take these 2 cover bolts off. This one right here. And then this one over on this side. That'll pull this front cover off. You should be able to just slide that off. Then your whole motor housing will be loose. Be careful, there are some parts up here that will be free. Your hot end will be out. And then we can go ahead and pull the wires for the extruder motor. We can work it all the way back to the control box. So I've removed the sleeve, and since we have to replace this back printed part, all these wires run through here. We are going to have to unplug a few things, so let's go ahead and get that done. So our extruder motor is the bottom one over here. We'll unplug that. Then we'll need to unhook the pin to probe. That's this one right here. And then our filament sensor cable right here. Then our hot end fan. This one's kind of hard to see. It's down here underneath the thermistors. And our part fan, which is this guy. Has a red label on it. It's right there. And I'll show you how all this goes back here in a moment. But now I'm just going to pull them all through the printed part. Now that the stock extruder is apart and all the wires are loose, now we can go ahead and take off the X carriage part right here, remove the belt, and put our new part on. So I'm just going to pull the belt with a pair of pliers. We'll have to retension it, of course. We can pull the filament sensor wire out and then cut these zip ties. There are a handful of nuts and square nuts in here that you can reuse. And our new X carriage piece will load 5 square nuts, 2 here in the top, 1 down here in the center, and then 2 down here on that bottom ledge where the bottom bearing goes. And that should be good for this piece. And then on the back cover, the new part, we will need a 3mm nut down here to hold on the wire management. So go ahead and put that in while we're at it. So we're good there. And also while I'm here, I'm going to go ahead and load my zip ties in my Y carriage part. We want to load them from the bottom so that when they're tightened, the head will be at the top. So we'll put one right there and one right there. And I'm just going to leave this carriage piece off for now because I'm going to attach the extruder body, that Bondtech body, on here before we install it on the printer. But now we need to move to harvesting some more parts off the existing Prusa config. As I said before, we are going to be reusing our Bondtech gears. So I'm going to remove this one off the old motor shaft. Some of these are glued, by the way, just in case you can't get this one off. And the only way to really remove that would be heat. Just keep that in mind if you run into a problem. We'll slide ours off. And then on the idler door assembly, we just have a pin that we're going to press out. I usually just use an Allen wrench. So we've got it out. We'll hang on to that shaft. There are bearings inside here, roller bearings we don't want to lose. And here's just a quick rundown of everything we're going to be reusing that we took off the extruder housing from the Prusa. You've got your sleeve for your wires, your pin to probe, filament sensor, that 7mm steel ball for the filament sensor, about 4 square nuts, an M3 nut, a 2mm screw that holds the filament sensor on, your Bondtech gears of course, your part fan, your hot end fan, and then the magnets for that filament sensor housing. That should be about everything. So these are all the pieces that we're going to be replacing, and just for reference, this assembly weighs in at around 342 grams. That's with some of the hardware. I do still have the gear on here, but it's going to be kind of close. The Bondtech assembly that we're going to be replacing it with roughly the same amount of hardware, weighs in at around 251 grams. So the weight savings can definitely help with certain aspects of 3D printing, like speed, ghosting artifacts, ringing, things like that. Now we're ready to go ahead and prep our housing. Now mine came with the motor installed. There's a gear inside there that's installed as well. But let's go ahead and pull this apart. You should just be able to separate it. And you can see the gear inside that's on that motor shaft. It's powering this larger gear. You should just be able to slide that out as well if you want to take a look. And then the motor has this one screw right here. We'll go ahead and loosen that up. You don't have to do this, I just want to show you what it's like. We have another one right here. And then another one down in here. Again, I just want to show you the assembly, so I'm going to pull it apart. So if you have to assemble one of these, you want the gear that goes on the motor shaft here. You want that bottom gap to be around 1mm. I'm going to install mine with the motor connection going down. You can put it out to the side if you wish over there, but we'll go with the stock location. The first screw, the one that runs through here, is an M3 by 8mm. Then the one right here is an M3 by 25, and then the one up here is an M3 by 12. Now that we've seen how the motor goes on, you will also need a square nut up in here. It should be installed, but just make sure it's installed before you continue. Then we will move to the other side of the housing. And first, let's start with our filament latch. Bondtech does give you a printed part to replace the existing one. We'll insert the small magnet into that lever arm, just like in the Prusa kit. Our lever will sit down inside the body. This part of the lever will actually be kind of through the top here. So you kind of put it in a slant. And then you hold it in place with an M3 by 18mm screw. It doesn't need to be too snug because it does just screw into the plastic, and it still has to move to be able to engage. You get that M3 by 18 from the Prusa kit, by the way. And then your longer magnet goes in this slot right here. Make sure that magnet is repelling this arm. Test it a couple of times just to make sure that it's pushing. If it isn't, you can flip that long magnet over. Then we can install the idler gear, the Bondtech gear that's from the Prusa, on the door. Make sure both of those roller bearings are inside the gear housing still. It is easy to just have one in there and it's still installed correctly. But then it drops in the idler door right like that. And you can kind of press this pin down in here so it snaps, but I like to just push it through from the other side. I just use an Allen wrench to push it through. And back to the motor side, the other side of the housing, I did tell you about this square nut over here, but we also need one over here. That one is kind of tricky to get on because it's over a well for this motor mount screw. But press that in there before you go any further. And then we need to put our larger gear back in. You kind of have to angle it in around that gear. Then we can put the Bondtech gear on, the one that has the grub screw. And the teeth for the filament path will go up from this orientation. There is a flat spot on this shaft that we need that grub screw to line up with. So we'll just slide it on just like this. And then we're just going to tighten up that grub screw a bit because we will need to adjust it after the fact, just to keep it from sliding off. That's tight enough, and it is pretty easy to tell whether you have it on that flat spot or not. If you do have it correct, that grub screw will be pretty much flush with that gear. So here's our hot end. You might actually be able to get away with using that stock tube, just cutting it, but it's probably a great time to replace it anyway. Now, I happen to have some extra tubes for the Prusa that have the chamfer already on them, so I'm going to use it. But it really isn't that big of a deal to put a chamfer on it with a hobby knife. Just be careful, don't hurt yourself. But I'll just take this old tube out. And chamfer side down, we'll slide into the hot end. We want to make sure we pull up on this collet to make sure it's gripping. And then we'll slide it into our cutting jig. And then we can just use a razor to cut it to the proper length. And there we go. Then we'll go ahead and slide on our 3D printed collet clip that comes with this kit to make sure it stays in place. Now back to the housing with the filament sensor in it. This is actually the back of the housing. A note, if you're using the bare mount, this spot right here, you can put an M3 nut in there. That lines up with the bare style mount. We don't need it for this build. But we can go ahead and put our hot end in this housing. It kind of goes in at an angle so you can get that PTFE tube right there. And the wires for the hot end and the thermistor go on the opposite side, the other side from the pin to mount. And then they head on back. That's pretty much the stock location. Now we should be able to line up both sides of the housing. I'm just going to flip this over and put it on top here. You'll have to have the gears line up correctly. They'll go into that bearing, and then you have the pin for the door right here that has to line up. It should line up fairly easily. You shouldn't have to force it at all. If it doesn't, you need to adjust something inside here. And everything fits nice. If it's fitting correctly, that hot end won't move around in there at all. It'll grip it pretty tight. Now we need to adjust that Bondtech gear. And the easiest way to do that for me is to just get a really small hex wrench, Allen wrench, and put it down in here in the filament path. So you can see those teeth line up with it. And then you can finish tightening up that grub screw. The sharp edges of those hex wrenches do line it up pretty well. You might have to spin it a bit to get to your grub screw, and we can just tighten it up. Now the documentation does recommend you use Loctite on this. I don't like to do that until I get to a permanent situation. I'm just kind of mocking things up right now. I don't want to have to break Loctite loose unless I absolutely have to. So we'll just tighten it with the wrench at the moment. But consider that if this is going to be your permanent install. And we should be lined up. Now for the pin to mount on the outside here, I'm going to go ahead and put in the square nut. That should work for the Mark III build. And now we can go ahead and put our X carriage on that we prepped before. It'll go on just like this, and we have some M3x40 screws to put it all together. These do come with the Bondtech kit. You have one up here, one right here, and then one over on this side. Make sure that housing again is lined up before you start tightening these. You don't want to disrupt any of the gears by having this off just a little bit. And with those three tightened down, we're still looking good. Now we can go ahead and put on our motor wire that came with the Bondtech kit. We'll plug it into the motor side, and then we'll route it through this valley right here and out the back, similar to how the stock Prusa kit does it. And with that in there, we can go ahead and put on our hot end fan. Leave a little slack on the top, just like the stock install. Then there'll be 4 M3x12mm screws in the Bondtech kit. They just thread into the plastic. Don't get carried away. You don't want to strip them out. It just needs to hold that fan on. But one for each hole. Make sure you're not pinching the motor wires or the fan wires when you're putting this on. The fan is on. I also did want to mention there is a Sun-On brand fan that does have a little higher output. That's a direct swap out for this fan. If you're not happy with the Noctua, I've never had a problem with it, but others have. So just note there is a compatible part if you want to buy one. Now we have the printed part for our hot end fan. You just need to put a couple of M3 nuts inside there. Comes with the kit. And we'll use an M3 by 10 millimeter screw through this hole up here, and then that installs on the housing in this brass insert right here. Then we can put our fan duct on. It screws into this brass insert right here. Another M3 by 10 millimeter screw. This duct does also come with the Bondtech kit right there. And then we can put our part fan on. It's a stock part fan. We'll need two M3 by 20s so they can run all the way through the fan housing into those M3 nuts. These are supplied with the Bondtech kit. And then we have a little keeper up here where we can put our fan wires to give it a little slack, and then it runs back through that channel. Then we'll do the pin to probe, and for this install we're going to use this front hole for the probe right there. And then in back here we'll have an M3 by 16 millimeter screw in the kit that'll hold it on. Remember, we put a square nut back here before. Just snug that up for now because we will have to adjust it. And we'll loop our wire around just to give it a bit of slack. Then we'll feed it through that channel towards the back of the printer. Now to the top of the extruder, we'll go ahead and finish up our filament sensor. We have the sensor guide with our 7mm ball. It'll slide in there. That sets inside the body, just like this. There is a printed part in the kit. It goes down in there like that. Make sure you can see that ball in that hole, and mind your filament arm. You don't want to clip it while you're pushing that in there. It can be kind of challenging to get in. You might want to test it with some filament or something just to make sure that ball is moving that arm down in there correctly. And it looks like it is. And I want to make sure one more time that my Bondtech gear down here is lined up successfully with my wrench. It still looks good, and I am triggering that ball, so the filament sensor should be okay. And then we can go ahead and close the door and put our thumb screw on. I usually like to tighten these up snug and then just back them out one turn. That's usually a pretty good starting setting for these. Then we can go ahead and set our filament sensor back in here. Remember, be careful when you're handling these. Try not to handle any of the sensor parts. And then put your 2mm screw back in. Then we can go ahead and plug in our wires. The clip should go up. Just make sure red, white, and black line up with 5 volts, signal, and ground. And we can put the top cover back on. I think I said before that you could reuse the stock one. Bondtech actually supplies you a printed one to go in here. So it'll go on just like this, and they give you an M3 by 10 to screw it down into that top brass insert. Just like that. And I did mention before, there is one of these that has a piece of PTFE that runs down in here, but that was the previous version, I believe. I just got confused on that. But if you have one of those, you can use a spare piece of that PTFE and cut it and put it down in here. It's just kind of a guide. But this one doesn't have it. It goes right into the top. And it's pretty much complete. We're ready to go ahead and put it back on the printer. Back to the printer, make sure all your square nuts are still in your X part. These like to fall out on this design. It's kind of maddening, actually. But we've still got the hot end and thermistor wires plugged in. So I'm going to go underneath the X carriage, just so I don't have to unplug them. That's just one more step. And then we can just kind of set it on here on the X carriage. And then we'll kind of mind our wires. All of these go under the belt, except for the filament sensor, of course. We'll pull the hot end fan and the extruder motor wires through. And then the other side, the pin to probe and the part fan. Then we can go ahead and make sure the bearings are lined up. Then we'll go ahead and fasten these top zip ties, just to keep it from moving around. Remember, the heads of these should be at the top. We'll go ahead and clip them. Then we need to put our belt back on and retension. I'm going to go ahead and fasten this side. I'm just going to push it back down into this 3D printed part. I use an O-ring pick to do this. And just by holding it up here, we should be relatively the same length. But I'm going to go ahead and loosen this motor up here in the front. So I'm going to go ahead and back these two out, loosen this one up, and loosen this one up down here, just so I have play in the motor, so I can get that belt on. we'll move it towards the printer, and we'll put the other side of the belt on. It should be the same length, so I'm just putting it pretty much the max that you can here down inside the part. We'll start there. If we need to cut it, we can. But they're both in there as far as they can go, so that'll give us the longest amount of belt in case we need to adjust it. And then we can go back to the motor. With this top one backed out, I'll just get these other ones started. And it's pretty good before I even tighten it up. I'm just going to run this top screw down just a bit. I'm pretty good with that. And then I'll go ahead and tighten these other ones up just to make sure we've got the proper tension. And that looks pretty good. To the back of the printer one more time. Now we're going to put the back of the X carriage housing on. We have to run all the wires through this hole. So we'll do the Pinda, the part fan, the extruder motor, and the hot end fan. Remember, make sure you have your M3 nut here on the other side so you can put on your management piece. And then the filament sensor wire will actually run over the top and in this channel back here. We also want to add our piece of nylon. This runs through here, and it gets pushed into this hole down here. So we'll push that in. You might want to use your pliers for that. It goes in roughly a millimeter or so. It should fit in there pretty snug, and then we can go ahead and slide our back piece on. It installs with 5 M3x10 screws. You should have been able to harvest all those from the Prusa. I like to start at the top and work the way down. 2 up top, 1 in the center, and then make sure your bottom bearing is nice and lined up, and then 2 more down at the bottom. And those are on. We can go ahead and run our filament wire down through this channel and put our wire management piece back on. It goes down here underneath. It goes with the larger channel facing up. Now we can go ahead and put our wire sleeve back on, get it started, and then make sure the opening is facing down because we're going to add the hot end and thermistor cables. We're going to add those in there as well. We can go ahead and run these to the end. I like to get the 3 zip ties for this one on first. They go through the lower holes in this management piece. Put the heads to this side, at least I do. Then we'll wrap the heads where they're on top. Then I feed the wires from the hot end into the bottom. Then 2 more zip ties to secure those hot end wires. With that done, you can give it a little twist to kind of shorten it up a bit if you need to. And now we can go ahead and put all our wires back in our case. We've got the strain relief clip back on. Let's go ahead and cable it back up. We've got our Pinda probe wires. It's the only 4-pin clip over here. Goes right there. We never unhooked the hot end or the thermistor, so that's still intact. Down here, these sets of pins, that's called AUX 3 or EXP3, one of the two. The bottom row is where you want your filament sensor. You want the red wire on the outside. Our hot end fan goes underneath that green wire right there. That's the bed thermistor. Hot end fan plugs in right underneath that. And then the part fan goes right next to it. And then finally, our extruder motor goes underneath all the other motors right there. And there we go. Now we should be good. We can go ahead and close it up. So I'm going to go ahead and power up. We do need to make some firmware changes because the gear ratio on this one isn't going to be the same. So I'm going to cable up USB and let's take a look at it. So let's just start in Pronterface here real quick. Do an M503 to spill out the firmware settings. This is what's in EEPROM. Notice we have E steps up here at the top, this M92 command. It's currently set to 280, and we are at 32 times micro stepping. That's probably going to be the biggest difference, and maybe the direction that the motor turns, because gearing it a certain way, that might change the direction. I'm not sure on this setup, but there's going to be a little bit of difference here. You could probably get away with setting this in the EEPROM, but Bondtech also offers a firmware version that does all this for you, so we're going to go that route. There is a page out on the Bondtech site. I'll leave links to all of this, but it tells you what the firmware differences are and for what version you might be using, whether you have a Slice Engineering Mosquito or whatever it might be, the Magnum. we have the Mark III's all metal V6, and we're using the INC board. So we're going to grab this build. 3.93 is the current Prusa version. They keep these pretty up to date. We'll head to Downloads, Extract All. There'll just be a hex file in here. We can load that with Prusa Slicer. We'll go to Configuration, Flash Printer Firmware. I'll make sure I'm disconnected from printer face. It shouldn't matter. It already knows we have a Mark III plugged in. We'll browse, and we'll grab this Bondtech version. And flash. The flash was successful. Let's go back to printer face one more time. Connect up again. I'm going to do M502 to bring in the hard-coded settings, M500 to save, and then M503 again. And you can see the E steps changed to 415, and they brought down the micro-stepping from 32 to 16. So those are the changes they made for their configuration. They've also altered the filament load unload because the lengths are a little bit different. But those are the major changes that I see. So now with the firmware flashed, I'm going to go ahead and power off because we need to adjust our pin to probe real quick. We'll just bring it here to the front. We'll bring the Z down manually so the nozzle is touching the bed. Make sure it is clean. You want it just touching, and you want the pin to around 1 millimeter higher than the nozzle. So we'll slide a zip tie under there. We'll set the pin on top of it, and then we'll tighten it up. That should be a good starting setting. We can adjust the rest with the first layer calibration. So now that the pin probe is adjusted, let's go ahead and power on. I moved the Z rods around a bit, so I want to go ahead and recalibrate Z. So we'll just go into calibration, and I'm just going to do the calibrate Z. We don't need to do the whole XYZ. And as long as your probe is working correctly it was before and you have it hooked up, your LED's on, and you have it set to that zip strip height, it shouldn't cause any damage to the sheet. It should work just fine. So we're all the way to the top. And then we'll just run our quick 9-point level. So we should be good there. Now we need to do our first layer calibration. I do have a couple of sheets stored here. I have my smooth sheet selected. I'll have to redo both sheets, but we'll just start with the smooth one for now. Back into calibration. First layer calc. I'm going to let it go ahead and reset, start from 0, because we don't know what's changed. And we'll select PLA, so it'll start preheating. I loaded some filament up. We'll go ahead and do our full 49-point level. Then the print will start, and we'll start adjusting. I know it's going to be a whole lot lower than 0, so I'm going to go ahead and start cranking it down. And I'm pretty happy with negative 0.75. And our test print looks pretty good. We'll go ahead and clear that off. Now we're pretty much ready for our next round of test prints. You might want to consider doing an E-step calibration on this new extruder. I did go ahead and check this one, but it's pretty much spot on the stock settings. But not every extruder and filament is going to be the same, so you might want to go ahead and run through that process. I'll leave a link to a video where I do that process if you don't know how to get that done. But let's go ahead and start some prints, and we'll take it to the time lapse once again. And now let's see just how we did. Let's do a side-by-side comparison of the before and after print quality. And with the side-by-side, let's go ahead and start again with our 6-sided polygon. I am going to show you like for like, side for side, so they should be the same. This side is stock. This side is with the Bondtech upgrade. Again, if we take a look at the stock print, if you look really close, you can see some imperfection in that layer quality. On the Bondtech print, it's much less noticeable. There is still some there. It's not completely gone, but not as much as the stock configuration. And that 45-degree artifact, if you take a look at it in the right light, you can see it in here on the stock print. It does not appear on the Bondtech print. So it has resolved that issue for this print. So I would say there is improvement here, but you have to look really close to see it. Then our benchy prints were kind of in the same boat, no pun intended. This is the stock, this is the Bondtech. Layer consistency, you can see it's just a little bit rougher in here than it is on the Bondtech. We still get those lines here on the wheelhouse when it jumps back and forth to the bow. That's probably more about kinematics than it is extrusion. The extrusion on the back is pretty much the same. It'd be tough to call if one was better than the other. Same for this side. It would be pretty hard to tell if one was actually just a bit better than the other. They're pretty close. The benchy would actually hide quite a few of those issues that are normally seen on the Mark III. Maybe the Bondtech is just a bit better. Again, really hard to see. Then we move to our 40mm test cube. You see the exact same type of thing. There are more inconsistent layers on the stock one right here than there are on the Bondtech. But any larger artifacts there are, like this line that runs down the middle of both prints, they're still going to be there. I think the blank side actually tells a better story than the other sides do. But if you hit it in just the right light, you can see stock a little more inconsistent than the Bondtech. Very, very close though. And then the larger boxes. Remember, this is a 2-wall print, no infill. I think this one was actually the most interesting. So we have stock right here. Take a look at it again as we lean it up. You can see some of that layer inconsistency. And then look at it on the Bondtech version. You see that really faint 45-degree? You notice there's really fat stripes in there. So it's not the same artifact that we see from the Prusa, it's just a little bit different. I'm not 100% sure what caused that, but remember, this is the Bondtech upgraded version. But the layers are definitely a lot higher quality. Side by side again. Stock, Bondtech. Bondtech is more even. But just in the extruder artifacts, of course, not in the actual kinematics. The larger ones are going to be caused by something physical on the machine. So there is a minor improvement here, but one artifact that's been added that I'm not really sure how it's caused. Then one last comparison that I did that I thought was somewhat interesting that I didn't show you before, but this one is from the upgraded Bondtech on the Mark III. This is from my Prusa Bear. My Bear is just an aluminum frame Mark III. It has no other upgrades. It is a stock extruder. But on that cube, I would say the layers are a lot more consistent than the one for the Bondtech on the stock Mark III. But in the right light, on the Bear print, you can see that 45-degree artifact that you see on stock Mark III printers. And the Bondtech version on this print, it has it just slightly, but it's not near as noticeable as it is on the Bear print. Still, I think the Bear is more consistent. So there it is, the Prusa Bondtech Extruder upgrade is now complete, and you've seen some of the test prints. The question is it worthwhile doing this upgrade on your 3D printer? I mentioned this before, but this upgrade is $110 US. And I used test objects that I thought would show inconsistency the most. And I put it in a whole lot of light at high resolution. And from what I've seen, I don't think it's probably worth your while. Now, if you have to have the absolute most perfect print quality known to man, maybe this is an upgrade you want to do. But for most users on most 3D prints, you probably won't even notice a difference. you might want to invest this in something like a Prusa Bear kit to make the mechanical properties of your 3D printer as solid as possible. That would probably be more bang for the buck. These are just my opinions, and I'm just testing on the machine that I have. Not every 3D printer, even the same branded model, are going to be the same, so your mileage may vary. So hopefully you at least found this interesting. That is it for today, and I will see you very soon on the next one.